Okay, part C, use separation of variables. That's the SASSY method. Use separation of variables to find b of t. Don't worry about this y thing. They're just saying if you plotted b of t on a graph, you would make the b of t values the y coordinates. So don't worry about the y equal. That's no big deal. We've talked about how the solution, the particular solution to a differential equation is the equation for finding the amount. We have the formula for the rate. We use the SASSY method on that formula to go find the formula for the amount. That's what they want in part C. So I rewrote the rate formula. I separated the variables. That's 1 point. I like to write -1 times b to avoid some mistakes, because this is an ax plus b form. Now when I go to take the antiderivative on this line, I use the ax plus b rule. So 1 over a multiplied by natural log of the absolute value of that ax plus b thing. The derivative of a constant is just going to be 1/5 t. There's your second point if you have the antiderivatives correct. For a third point, you're supposed to take this information and go find the constant c. So I plug into b a value of 20 and into time a value of 0. Working on that, I get this point. The value of c is -ln of 80. So far I'm at 4. Now I've got to get that last point. If this is hard for you, just skip the last point. Don't worry about it. Just go do something else. A lot of steps to get this last point. So I take this equation right here in blue, and I plug into that equation my value of c. I get rid of the -1. That gets me to here. Now I'm going to get rid of the ln. So I take both sides of the equation, make them exponents of e. Then I use this rule here that says, it's on your golden notes, the rule is e to a power plus b is the same thing as e to the a multiplied by e to the b. You've used that before. It's kind of like saying x to the 2 plus 5. It's the same thing as x squared times x to the 5th. That's exactly the same rule. And everybody knows that because that would be x to the 7th. So that's the rule I'm using. That gets me to this line here. Now I use e to the ln of whatever is just the whatever. E to the ln of whatever is the whatever. So that gets me to here. To get rid of the absolute value bars, you must consider that what's inside the bars, right there, could equal exactly what we had. Or there are some cases where what's inside the bars will equal the -1 times what we had. You have to figure out which one is right by testing. So we plug in a b value of 20 and a time of 0, and we find that this equation is true. Therefore, that's the correct answer. We rearrange for b. That gives us our 5th point.